Hello students, in this video we're going to learn a new operation called the set difference operation. The set difference operation or written as the minus operation has this symbol, has the following format R1 minus R2. So it's a binary relation because it works on two relations. What does the following relation will return for us? It will return all tuples or all rows that belong to R1 but not R2. So these rows only must belong to the first relation but not for the second relation. So as if you are making subtraction here, so only the elements of the first relation will be found in the result, and the elements or the rows in the second relation will not be found in the results. So in terms of sets, we can write R1 minus R2. This will give us a new relation or a new set. The elements of this sets are tuples T such that each tuple T must belong to the relation R1 and T does not belong to R2. Also, we have a condition for using the set difference that it requires that the two relations R1 and R2 must be union compatible. This means that they must have the same number of columns and the same domain for corresponding columns. Let's take an example here. If we have this relation R1 with three rows 1, 2, 3, and with three columns A, B, C, and another relation with also the same columns A, B, C, and with four rows, and I want to compute R1 minus R2. So this will return for us all the tuples that are found in R1 but not in R2. So first of all, let's go for the rows in R1. The first row is A1, B1, C1. This will be in the results only if it's not found in R2, because here only the elements in R1 that are not found in R2 will be in the results. So A1, B1, C1 will not be in the result because it's found in R2. So as if you are making A1, B1, C1 minus A1, B1, C1, which will cancel each other. So this will be cancelled with this. A2, B2, C2 will not be found in the results because there is A2, B2, C2 in R2. So this one and this one will be cancelled. A3, B3, C3 will be found in the result because there is no here A3, B3, C3. Okay, now we will finish computing R1 minus R2. We don't loop over the rows in R2 because R1 minus R2 returns for us only the results or only the tuples that are found in R1 that are not found in R2. So A0, B0, C0 will not be written here because A0, B0, C0 belongs to R2, and this is and this can't be true with the definition of R1 minus R2. Also for A4, B4, C4. Let's take the intersection operation, and this is the symbol for the intersection operation. How it's written? It's written as R1 intersection with R2. The semantics or the meaning of this operation, it will return all tuples or all rows that belong to both R1 and R2. So this will return all rows that must belong to R1 and R2. So in terms of set, we can write R1 intersection R2 is the set of tuples T such that T belongs to R1 and this tuple must belong to R2. If a tuple belongs to R1 and this tuple does not belong to R2, then it will not be included in the result. How to derive the intersection operation R1 intersection R2 from existing operators? We can write R1 intersection R2 using this way or using this way, R1 minus R2 or R2 minus R1. This is because R1 minus R2, this will returns all the tuples that are found in R1 and not in R2. And next, if we exclude these rows or the results of these from the results or from the relation R1, this will give us the relation or the tuples that are found in R1 but excluded the first time here. So this will return the intersection between these two relations. Here we have, he's telling us that the union and the intersection operations are commutative, because this means that you can switch between these two like the following. If you have R union S, you can write S union R, the result is the same. R intersection S is the same as S intersection R, these are the same. However, union and intersection operations can be applied to any number of relations, and both are associative. So also, if you have R union S union Q, you can write it in this way: S union R. You first compute the S union R, then this result is union with the Q. R intersection S intersection Q can be written in this way: R intersection R intersection Q. This is the meaning of associative. This means that you can change the position of the brackets between any two relations. The difference operator is not commutative. This means that if you have R minus S, you can't write it in this way, S minus R, because this will return the different result. Okay, let's finish here, and in the second video we are going to study the Cartesian product operation, and this is the symbol of the Cartesian product, so stay tuned in a next video.